So, as she said, my name is Paige Howell, and I'm going to start by saying it's been a long day, it's been a long week. Let's just begin with the viewing exercise. So, what do you see in this picture? Is it that gorgeous milky white water? Is it the swirling blue-green in the lake? Is it that fragmented brown and green farmland that surrounds those meandering streams? Well, there's a lot to notice in this picture. And although it's beautiful, and I could stare at this for hours, a picture like this might be some source of grief to a local environmental planner in this region. So, before I get to talking about the research that I did and my senior thesis that I created at UC Santa Barbara, I'd like to give us all some definitions so we're all on the same page here. So, what processes am I alluding to in this picture? Well, I'm sure many of you know in this room, I'm talking about eutrophication, runoff, sedimentation, deoxygenation, and dead zones. But to give us a brief overview, I'm just going to talk about what those things really mean. So, an increase in nitrogen in a water column can cause a huge jump in primary productivity. And although that's a great thing for the plankton that might live there, it can seriously deplete the oxygen in the water column. And as a result, you can end up with less oxygen for the other mammals that need it, other species. Another thing I mentioned was sedimentation, and we've talked about this a little bit in this conference, but sediment, although tiny and seemingly harmless, can absolutely bury species over time. And a lot of these farmlands have loosened a lot of sediment, and as a result, they're burying what might be on the coastline there. So, we've had an impact, right? We've had a very impressive impact on a lot of these coastal regions where, although it might not look like there's a lot of human development along the coastline, you don't see any resorts or houses or beaches, we're still really impacting a lot of the species in these coastal oceans. So when I became aware of this in college, I really thought, wow, I cannot believe this does not have more attention. So I decided I wanted to make a tool. And I wanted to make a tool that would benefit local environmental planners that are tasked with making sustainable practices for regions like these. And in an effort to make a very effective tool, I first really needed to understand, well, what problems do these planners face? So let's talk about that. So first of all, they need to assess the health of the region, right? And this is a very broad methodology that a lot of these planners are given. So some of them, they get aerial photos. Some get like a written field report that's a bunch of dense paragraphs. Others might have to go to the region themselves and decide, okay, what's the health? What are we dealing with here? So after that, they need to come up with their own opinion, their best scientific knowledge of, okay, what practices do we need to be enacting in this region to preserve the species that we have? The problem with this is that they're more often than not given the time that they need to do a very extensive overview. And I'm sure given enough time and given enough money, you could go in and take so many in situ observations and measure the oxygen and measure the species and come up with like a really great plan. But if you're not given enough time, it's really hard to make these critical decisions for your area. Then finally, so you have your framework, you come up with your plan for your region. You have to communicate and package that information for stakeholders and people that might want to develop in these areas or people that might be involved here. You have to justify the reason why you can or cannot use this area, which is much easier said than done. Not everyone is as conscious as we are. So what I decided to do, did a literature review, and I thought, I'll do a risk analysis. So a risk assessment is a very well-studied, a very common approach to assessing situations like these. I put a general framework up here. This is from Allen et al. In 2004. I'm sure many of us are familiar with this. So we're taking into account, the current health status, our best understanding of the region and statistics, and a lot of guess and check. Like in Kelly's presentation, it's a lot of fitting models and kind of checking, okay, did my assessment kind of show what I think is going on? So it's a little bit of a challenge, but it's better than nothing, and it's fast. It's very fast if you have data. So this is well studied, and moreover, it's well studied and well reviewed in the literature for ocean environments. So I read these papers, and I thought to myself, I'd like to apply these to a GIS context. I would like to give them some real great visualizations and try to make a pretty palatable tool for local environmental planners following these practices. So, how did I do that? Well, I first started with the question of, what do I mean by risk, right? Risk is an ambiguous term. So in the case of this presentation and of this project, I defined it as risk of loss of ecological diversity to your coastal area. So then I had that nailed down. That's what I mean by risk. Then I had to find a framework, a piece of literature that had already come up with a management plan that evaluated ecological risk and species loss risk. So I found one. Awesome. On a good start. You define the extent of my study, and bear with me here. As a junior in college, I was like, the globe. So I decided the whole Earth would be the best extent to study a problem for local environmental planners. Bear with me, but I actually had a great time doing it. So I'm just studying on an Earth globe scale. And this is a GIS crowd. I don't really need to belabor the fact that I needed good data, right? We don't need to sit here and mull over that. So I needed something that was similar in spatial and temporal scale from a credible source. And finally, I want some sort of statistic to analyze my result, right? Because I can say, this is my risk analysis, but I need some sort of meat to decide, okay, well, is this really true? So I put this to work. And this is actually going to look very similar to Kelly's presentation, which is really, it's funny and it shows that it's not impossible to evaluate risk to your region. It's kind of funny. We had a very similar workflow. So what I started with was that environmental planning framework that I first talked about. And this one was taken from Friedstone et al. And this work was done at the Bren School of Environmental Science at UCSB. So these were the 4 layers that she determined to be pertinent to coastal risk. And so I took these and I was like, okay, let me find some layers that satisfy these questions. And so where on earth was I going to find this great data that's global, from a credible source, that's identical in spatial and temporal extent? The Living Atlas. So I found all of this data on the Living Atlas via the Nature Conservancy. It was a great resource, and I loved using it. So plug for the Living Atlas there. So I took these layers, and then I categorized them a little bit further, one into a nitrogen score, another into a sediment score, and finally a population score. So I had these 3 scores. I then, after a literature review, applied weights and ended up with a very simple risk analysis, 1 being low risk, 5 being high risk, very severe. So the gears are turning. I'm producing work. I'm like, great, this is awesome. This is so cool. I'm making science happen. But I had a little bit of a problem. I sat down, I thought to myself, I'm evaluating risk of loss of ecological diversity. How on earth could 1 set of weights capture this accurately for a whole ocean? We all know how diverse our ocean is, and nitrogen is not going to affect every species in the ocean the same. Sediment will not affect every species in the ocean the same. So I decided I'm going to make 3 separate models off of big global extent ecologies in the ocean. One being seagrasses, the other being mangroves, and the final being corals. So I figured out weighting scales for these 3 separate ecologies, and I put my work on a map. So first, we're going to look at seagrasses. And to explain the symbology, the color of the circle is darkest being highest risk, lightest being lowest risk. The size of the circle is how many species of that ecology are present. So seagrasses, 38%, according to my analysis, were severely impacted. That's a risk score of 5, the highest score you could get. Seagrasses were unique to mangroves and corals because they were so large in geographic extent. Okay, so we moved on. Next was stony corals. 34% of stony coral area was severely impacted. And although this number is lower than seagrasses, corals are so diverse. And so in those areas that they were impacted, a far higher number of species was impacted than seagrasses. So if we're going by area, seagrasses were the most impacted. If we're going by number of species, corals were the most impacted. And then to mangroves. I captured that 21% of mangrove area globally is severely impacted by risk of ecological diversity loss, but I want to point out that this does not capture direct on-land human deforestation. And they talked about this a little bit in the Belize case study, that a lot of mangrove deforestation is happening on land. So this is a oceanic analysis, so I couldn't capture that. So of the 3, here's some general results. Embayed regions were reflected in my model, which was a good result. That seemed pretty accurate. I decided that although I had a risk score, it needed a little bit more to give it a priority. I wanted to give these areas priority. And then finally, for the highest risk areas of both mangrove, seagrass, and coral, it was pretty consistent with the literature, which was awesome. So I'm sure as you noticed on all 3 of these maps, there's one area in particular that is just a little bit of a hot mess, and that is Southeast Asia, as you can see right here. Wow, lots of circles, big, varying in scores. So I decided to take a stab at creating a priority index as well using this hotspot region. So I'm going to dive into that really quickly. So what's going on here? Well, I took the risk analysis and combined the number of species present in those areas to create a priority index. And in the central Indo-Pacific, 9 of the 10 top priority areas of the world were present here, 7 of the 10 for seagrass, and 8 of the 10 for mangrove. Yikes. So that's the end of the ecological results I'm going to get into today. This is a GIS crowd. I want to talk a little bit more about the GIS. So I decided to do a global model. I understand that this is not super useful for a local environmental planner. These are cut up into very large polygons, and obviously don't give much meat if you're looking in a very small area of your coastline, but I believe that this methodology could be very easily implemented if you had finite enough resolution data to a small section of coastline. I found that prioritization was easier to do than I thought, and it really did help give more context to my results. I also plugged the Living Atlas, and I loved using the Living Atlas. If you have data, please, please put it on the Living Atlas, because I, as an undergraduate at UC Santa Barbara with $0 and 0 cents, could find all of this really great information and produce something that I really enjoyed and got a lot of utility out of. And then finally, and I think this is the most important point, was I read almost all of these results in papers that were published years ago, but they did not have visuals. And even if they did have visuals, they conveyed nowhere near the impact that these conveyed. So I loved the fact that just a very simple spatial overlay and GIS could give so much more context to these really, really critical analysis. So I had challenges like any other project. The timescale. First of all, the personal time scale, this was done on my own personal time, and I did 2 majors, and I wish that someone would do this as a master's, because I think a project like this would really be appropriately done as a master's, and I think something like this could use a lot more time. It was difficult to test the validity. A little bit, like Kelly said, I didn't have a good data set to be able to cross-reference if this was valid or not. So if anyone has any ideas, please let me know. I'd love to hear about it. And then finally, how do I bring this result into practice, right? I made this and I published the story map and I got units, which was cool, but I'd like this to actually have some real utility in the world. You know, if no one's using it, then what's the point? I want to engage people with this. And finally, I had some future work put up here, but after what Dawn said yesterday, I loved her message of ocean optimism. This, although might not seem like an optimistic picture, this was a red tide that was in Florida, in Tampa, a couple weeks ago. But at the time, and I saw a really great viewer that NOAA had put up that was tracking, and it was using, an ArcGIS platform to show where this algal bloom was happening. And although these may be really scary challenges that we're facing, how cool is it that we can now put this information online and inform people? And although we need a wider audience, I thought it was really impactful that, something that's so scary and so seemingly so bad, we're getting great information out of it, and we're engaging more people than ever before. And I've seen so much important work at this process, and I've just really enjoyed it. So I'd like to acknowledge my graduate school advisor, Alexa, Benjamin Halpern of the Brent School of Environmental Science, David Valentine, and that's all I have for you today. Thank you so much for listening.